Hello class, welcome to our lesson for today. We are starting on a brand new topic, and this topic is formula and variation. Formula and variation. We will focus for the first part mostly on the variation bit, then eventually we will come to the formulation. So today we look at direct and indirect variation as well as proportion. In our next lesson, we are going to look at the first part about direct and indirect proportion. So let's be attentive about that. We'll talk about direct proportion. Okay, this is what we'll be looking at in the entire topic: direct and inverse proportion. We'll look at direct and inverse variation. We'll look at joint variation, partial variation, and then eventually the formulation bit. Now, what do we understand by formula? In real life, we want to see what will happen when you change one value to the next value, or to what we call the subject. You vary one value, and then you see what happens to the subject. For example, in the formula of finding the circumference of a circle is given by that formula: C equals to pi d, where C stands for circumference, pi is a constant, 22/7, and then d is the diameter. Now, what happens to the circumference if we double the diameter? What will happen? This is what will happen. The new diameter will be 2d, twice. And then that means that our new circumference will be pi into bracket 2d. So eventually, our circumference is 2 pi d. What does that imply? Because initially, circumference was pi d. Now it means that our circumference is 2 pi d. Our circumference has doubled. By doubling the diameter, the circumference is doubled. That means there's a direct proportion here. There's a direct relation between circumference and diameter. Double the diameter, you double the circumference. Okay? Good. So the circumference doubles, as you can see in this case. So when you come to talk about direct proportion, this is what I want you to learn. I want to explain what we mean by direct proportion. I want you to understand the idea of double proportion. And I also want you to be able to solve a simple direct proportional question. Okay? Whenever you get any simple direct proportional question, you can be able to solve it. Now, let's take this example of a direct proportion. You have two quantities. For example, the number of cakes and the total cost. These are said to be in direct proportion because the more cakes you buy, the more money you'll pay. So the money paid and the number of cakes is directly proportional. Now, I'll use an example which is based on sterling pounds. Sterling pound. So that means 100 pence normally make 1 sterling pound. I hope you understand this. It's just like having 100 cents making 1 shilling. So when you double the number of cakes, you double the costs of cakes, because they are directly proportional. Now, write down two quantities that you think are in direct proportion. Any that you can think about. Let's say the number of books, excess books you buy, and the costs. Or the number of pencils you buy and the cost. Okay? Now let's look at this example. The cost of 6 cakes is 4.20 pounds. 4 pounds 20 pence basically. Find the cost of 5 cakes. Now, generally speaking, if 6 cakes will cost you slightly more than 4 pounds, it means 5 cakes should cost you more or less than 4.20. It should be less. Because you're buying fewer cakes, the cost should be less. Okay? So let's take this example, cakes and cost. 6 cakes cost 4.20 pounds. What about 1? 1 will mean we divide that by 6 and we get 0.07 pounds or 70 pence. Now that means 5 should be 70 pence multiplied by 5, and that gives me 3.5 pounds. 3.5 pounds. So 5 cakes will cost me slightly less. So it is easier if you use this method, that if 6 cakes cost 420 pence, then 5 will cost less. 5 will cost less. Okay, so we're expecting it less. And that means 5 divided by 6, you multiply by 420 pence, and that will give us 350 pence, which is the same as 3 pounds, 3.5 pounds. 3.5 pounds. Pretty simple. Direct proportion. Which of these graphs here represents a direct proportion relationship? The last one wouldn't, because the last one shows that as you move from the 0 point to along the x-axis, the value is actually reducing. The first one is kind of as you move from the 0 point to the x, it's increasing, but it did not start at 0. The second one is a direct proportional graph because it starts from what you call the origin, from the 0 point. From the 0 point, and as you move along the x-axis, it also increases as you move along the y-axis uniformly. That is what we mean by direct proportion. Inverse proportion. Now, my intention is to explain to you what inverse proportion is, and I hope that you will understand what we mean by inverse proportion, and you can be able to solve any simple questions that involves inverse proportion. Good. Inverse proportion is when one quantity increases, the other decreases. These two quantities are said to be inversely proportional or indirectly proportional to each other. For example, if you're asked to fill in the following table given the values of x and y. Now look at the first one. And x is 1, y is 8. When x is 2, y reduces to 40. You notice that 1 multiplied by 80 is 80, while 2 multiplied by 40 is 80. So when x becomes 4, what do you think should be the value of y? 80 divided by 4, which will be 20. When x is 8, what do you think should be the value of y? 80 divided by 8, which will be 10. In all the cases, you multiply the value of x and y, you get your answer to be 8. Notice that x times y equals to 80, so that means they're inversely proportional. In the case of inverse proportion, the ultimate value of the multiplication is exactly the same. So that means as one increases, the other one reduces. Now, example here. It takes 10 men 12 months to build a house. How long should it take 8 men? Now again, if this is inversely proportional, it means that 10 men will take 12 months. If you multiply that is 120. So one person should take 120 months to do this work. What about 8? We divide by the 120 and get to be 15 months. Of course, 15 months. That's an inverse proportion case. Easier method to work this one is 10 proportional to 12, 8. Are you expecting more or less? Pretty much more, because we have taken less number of workers. So 10 over 8, this is what we call an improper fraction here. Multiply by the 100 by the 12 months, and you get our answer to be 15 months. So this is inverse proportion. I expect that by now we have understood what we mean by direct proportion and inverse proportion. How do the direct proportion graphs look like? I'm going to explain to you how a direct proportion graph is. It's always a straight line. It will be a success if you understand that it's a straight line showing a direct proportion, and that you can easily construct a direct proportion graph. Now, let's look at this question here. The table below shows the cost of packets of biscuits. One packet costs 20 pence, 2 packets cost 40 pence, 3 packets cost 60, 4 cost 80, 5 cost 100 pence, and 6 packets of biscuits cost 120 pence, about 1.20 pounds. Now notice that if we divide C divided by P, cost divided by packets, our answer is 20. That's the case of direct proportion when you're dividing. When you're multiplying, it will be indirect. So, in this case, we can construct the graph to represent this data. What type of graph do we expect? We expect a direct proportion graph, because that's what the table is showing. And there it is. When you have 0 packets, the cost is 0 pence. 1 packet, the cost is 20. 2 packets, the cost is 40. 3 packets, 60, and so forth and so forth. This is a direct proportion graph, a straight line from the origin. Notice that all the points that we have marked here are lying on a straight line. So this is a direct proportion graph. That's how we draw it. C is directly proportional to P, which means C equals to Kp, where K is a constant. K is the gradient, the change in Y over the change in X. And that K in this case is 20. So that's how direct proportional graphs look like. Two quantities which are in direct proportion always lie on a straight line passing through the origin. That's the key point. For example, if you were to plot these points, that's what you're going to get. After plotting them, you get the dots, and it's a direct line through the origin. Now that brings us to the end of the first part. In our second part, we looked at indirect proportional graphs and more of the same, direct and direct correlation. See.